Hi, everyone. I'm Rosie Haneke at UIC Library of the Health Sciences, and this is today's webinar. It's the last of 13 webinars that we did this semester on topics related to systematic reviews and other literature reviews. And today we're talking about citation searching, which is an essential step in your literature review. A rough outline of what I'm going to be talking about: citation searching, what is it and why do we do it? Why is it particularly important for systematic and scoping reviews? What databases can we use to help with citation searching? How do we do it, importantly? What else do we need to know? And then a brief talk about tools for visualizing a scholarly conversation through citations. So this is me. I've been at UIC Library since 2014. I'm associate professor and head of the Information Services and Research Department at the Library of the Health Sciences, and I am the librarian for systematic reviews and other types of evidence synthesis. So the topic for today is citation searching, which goes by a lot of aliases. So the term I'm trying to stick with for today is citation searching, but you may also see or hear people referred to citation tracing, citation tracking or chasing, snowballing, pearl growing or citation pearling, chaining references, harvesting references. These all are referring to the same process that today we're calling citation searching. And the simplest definition of what citation searching is following the references from a publication of interest in order to identify additional literature relevant to that research topic. And there's two components of this, which we'll talk about in more detail: backward citation searching and forward citation searching. Backward citation searching includes the references that the authors of a publication cited, so the references at the end of an article. Forward citation searching is who has cited that publication. And usually, almost always when we do this, we're talking about scholarly journal articles. Just to zoom out for a minute though, this is important to keep in mind no matter what kind of research you're doing, because references and citations, these are the ways that scholars demonstrate and list the other scholars that they're in conversation with. So if you want to follow the scholarly conversation that's already going on around your topic, citation tracking, citation searching is the way to do that. That's how we know who scholars, researchers, and other professionals are engaging in discourse with. And these are some professional standards. Addie put the link in the chat if you'd like to read more about the idea of scholarship as a conversation. What citations help us learn about the scholarly conversation? Very simply put, what do we know about this topic and where are the gaps? What discoveries in the past have led the field to where it is now? And similarly, how has this topic continued after a particular discovery? And how do various perspectives, on this topic support or diverge from one another? So there's a lot of different areas that we could discuss today related to citation searching. We're going to focus on things that are relevant to doing a systematic review or another type of literature review. But whether you're doing a systematic review, just finding a few articles, or if you're writing an extensive literature review, say for your dissertation, citation searching is really, really helpful. It can help you find articles that you simply won't find through database searching. So as I said, backward searching is searching the references of a given publication. This is something that we all essentially do naturally when we're reading a paper. If we read a point that sounds interesting, or you think, well, I want to know where they got that. I want to make sure I've read that because that sounds like something I should know about for my literature review. We follow citations and look up those references. So pretty simple, and as I said, we do it pretty naturally already. Forward citation searching refers to using a citation index, which is a type of database we'll talk about in just a moment, to discover who has cited a publication. So you really can't do forward citation searching without using one of these tools. For backward searching, all you need is the publication, and the references will be included in it. For forward citation searching, we're using a citation index. And here's just one example. Closing the Gap in a Generation is sort of a landmark report that came out in 2008. And if I do forward citation searching on it, I'll find thousands of articles that have cited this one. And this is just one particular example of a study that was done that cited this report. So I do want to, I think I can't overemphasize that citation searching in both directions is a critical step. As I said, it will help you discover relevant articles that haven't come up in your database searches when you're doing a systematic review. This is especially true if you're searching some abstract concepts that are difficult to pinpoint exact keywords to name, or maybe you're using the vocabulary of your field and there's another field that uses a different word to describe the same concept, so you didn't include that word in your search terms. And then also, it helps you find articles that aren't indexed in major databases. So for example, on a review that a colleague and I completed a few years ago, we found a highly relevant study using forward citation searching. And we hadn't found it because it was from a sort of a fledgling African open access journal, and it's not in any of the major databases. It ended up being a really important paper that we wouldn't have found if it weren't for the forward citation searching. And when it comes to doing the systematic review, of course, you want to demonstrate that you've left no stone unturned and cast a wide net when you're looking for literature on your topic. So it helps you demonstrate that your search has been comprehensive. Now, the only part of this that's mandatory, according to published guidelines for systematic reviews, is the backwards searching. So according to the MECOR standards, which you'll get a link in the chat, it's mandatory to review the reference lists of all included studies in your review, plus any relevant systematic reviews or other literature reviews on that topic. Forward citation searching is not as discussed in the standards and guidelines. So a lot of what I'm talking about today is really my professional advice based on my experience, but it's not published anywhere in any type of guideline. But generally, this is strongly recommended to do forward searching. And what's optional is what's called snowballing, which is where you find an article through citation searching and then look at all of their citations and keep going like that. And the snowball builds as it rolls down the hill. So that's highly recommended. I would really, if you're doing a systematic review, I would consider both of these a requirement, even if it's not established as such. In the Cochrane Handbook, they say that it's good practice to carry out forward citation searching on reports of studies that meet the eligibility criteria. So that would be your studies that you've included in your review. Another advantage of doing this that I haven't mentioned is that it helps combat publication bias or reporting bias, and find forward citation searching which will be a supplement to the database searches. So how do we do it when we're doing a review? How do we approach this systematically? Well, we're going to start by doing our database searches, screening the titles and abstracts, and then reviewing the full text of any articles that make it through the abstract screening stage. And then we'll do a final full text review and discussion of which studies should be included in your review. Once you get to that point and you have a list of studies that are included, at that point, that's when you do citation searching. So you need to decide what you're including in your review before you can do this. So again, it's a supplementary search method and it's done later in the process than your database searches. You take that list of included reports or included studies and review the bibliographies of each of them. It's really what I tell reviewers to do is just look at the full text PDFs that you already have saved and scan through the reference list at the end of those articles. You're just scanning titles and flagging or highlighting any titles that look potentially relevant. For those titles that you think that could be something relevant, that could be something that meets my criteria, the first thing you want to do is check it against your files in Confidence or your citation manager that contains all of the abstracts you already looked at. So you want to check your files and see, did you already screen it? And that'll eliminate a bunch of them right off the bat if you've already identified them through the database searches and screened them. If you didn't already screen it, if this is truly a new citation, you're going to paste the title into the main library search box or use our link to Google Scholar to find the full text. You're going to review it as usual. And then if that study meets your inclusion criteria, you'll add it to your review. There's a couple ways you can do that. You can just say, based on the person who reviewed it, we're including that in our included studies, or if you're using Confidence and you want to add it to the full text review stage at that point and have two screeners look at it and vote and discuss whether it should be included, you can do that as well. So we're looking at the reference list, pulling out anything relevant, make sure we haven't already found it, and then adding the relevant ones to our review. For forward citation searching, as I said, we're going to use a specific type of tool called a citation index. And there are three of these: Web of Science, Scopus, and Google Scholar. Google Scholar is publicly available, but you're going to use the UIC Library website to access all three of these citation indexes. Excuse me. So from the library homepage, you'll click on Database and then find the links there. They all essentially serve the same function in that you can use them to find articles. They're large multidisciplinary databases of articles, but they also track how many times an article or publication has been cited. So you can use them for this forward citation searching. Here's an example article that I looked up in all three of those tools. In Web of Science, over on the right-hand side is where you find what's called a citation network. So the way they have it here is a little bit confusing. It's been cited 56 times. Since it was published, it was cited 56 times. 53 of those were in the Web of Science's core collection, and an additional 3 were found in a supplemental collection. But in any case, you would click on this 56 to see those publications that cited this study. And then also at the end of the article are 53 cited references. So you can do the backward citation searching from this screen as well. In Web of Science, you would simply click on the 56 to see a full list of all of those publications that cited this one. And again, review the titles, look up any that look potentially interesting, and then add to your review if you find any new ones that meet your eligibility criteria. In Scopus, it works essentially the same way. This is the same article, and over on the right-hand side, it tells us that it's been cited by 56 publications, 56 documents since it was published in 2016. So I can simply click on that 56 to view the entire list. In Scopus, underneath the title and abstract of an article is where you'll find the list of cited references if you want to use Scopus to do the backwards citation searching. And then finally, as I said, Google Scholar um, does the same type of, it's a similar citation index. It's a great alternative if you're not affiliated with UIC or another institution that has Web of Science or Scopus, you can use Google Scholar for free. I circled the number of times this same publication has been cited according to Google Scholar. This number is almost always, I should say, going to be higher in Google Scholar than it is in the other two databases, simply because it searches a wider selection of publications, a wider subset of the internet, and it's more likely to include things in other languages. It's more likely to have duplicates. So it might give you an institutional repository version of an article and the published journal article. Sometimes it'll combine those, other times it doesn't, and it counts them as two separate publications. So that's why we see 68 here, and then it links back to Web of Science from Google Scholar if you want to see those 53 from the Web of Science core collection. Google Scholar is very easy to use. In general, it's hard to get citations. It's harder to get citations out of Google Scholar as a batch. So that's the main reason we don't always recommend it for the forward citation searching. Okay, so those are 3 citation indexes, and you can use those to look up articles that have cited a particular publication. What's the difference between using those and using, when you're looking in a database, you'll often see in PubMed a link to cited by publications. PubMed, PsycInfo, CINAHL, most library databases will have this feature. For example, this is just a example article from PubMed. On the right-hand side, you can see cited by, and that will take you to a list of articles that cited this one that we're looking at. And that's what that looks like. The issue with this, and the reason why this is not recommended is for systematic reviews, is that this is only showing you the articles that cite this one that are in PubMed. PubMed is a huge database. It's got, I don't know, 35 million records in it, but it doesn't include everything. It doesn't include things from other disciplines. It doesn't include journals that might be in Web of Science or Scopus. So if I use this feature in PubMed, it will help me find some or maybe even most of the articles that cited my included studies, but it won't find all of them. The same issue is true for CINAHL. This is a screenshot from CINAHL looking at the same, an article on the same topic. You'll see they specify time cited in this database 1, and that means that this article has been cited by one other publication that's in CINAHL. If I go to one of those 3 citation indexes, Web of Science, Google Scholar, or Scopus, I will likely find additional forward citations. If you're searching a database like PsycInfo or sociological abstracts on the ProQuest platform, we have a number of databases through the vendor ProQuest. They're owned by the same company as Web of Science. So in ProQuest databases, you can click out to see everything that's in Web of Science. But in general, this is something that we advise that you do as a separate step from your database searches and just go directly to the citation index to keep it simple. All right, so I wanted to go through the process step by step. If you're doing systematic review and you're at the stage where you have a collection of, let's say, 25 articles. These are the 25 studies that I'm including in my systematic review. And now it's time to do citation searching. So the first step, which I might assign to, review team member A, is to do the backwards searching on those 25 articles, scanning through the reference list at the end. The next step is to do the forward citation searching on this group of articles. And this is one method of doing that. This is what I typically do for my systematic reviews. So I'm going to walk through that process. I take that list of included studies and I look them each up in Scopus. And in Scopus, I'm signed into my free account and I add it to a saved list. So I'll usually just search by title, select the article that I want. This is the article that we identified and included in our systematic review, and then click the little 3-dot menu and save to list. This is an example from a review that I participated in on gestational diabetes. So that's why this list is called GDM Forward. So I did the initial database searches for this review. I uploaded it all to Covidence for the team, and they went through and did all their screening. They ended up with 27 studies that they're including in their review. So they sent me this list of 27 citations. I located them each individually in Scopus and added them to a saved list. So I can see those listed here. And then at the top of this list, you can see view cited by right there. And that will give me a full list of 2,000 documents in Scopus that cited at least one of the 27 documents on my list. So it's giving me a whole new set of articles that are the combined total articles that cited my included studies. I know I'm repeating myself a lot, but I just want to make sure I'm being clear. So I have 27 studies. If I do it this way, one benefit is that Scopus is going to automatically remove the duplicates. You can imagine that authors who are writing on the same topic are often citing the same publication. So if I look up each of these individually, there's going to be some duplicates between records. If I do it this way as a saved list and then view cited by, it's going to remove those duplicates for me. There's 2,403. I'm going to select all of them and export them to my citation manager. I use EndNote, but this could be Zotero or RefWorks, or you could import them directly to Covidence if you're using Covidence to manage your review. And the first thing it's going to do is check this against your existing files from your original database searches and flag all the duplicates. So if you have a comprehensive search at the beginning that you used for your databases, chances are you've already found a lot of these articles just with your keyword searches in your database. So of these 2,400, when I compare this to what the team has already screened for the review, it might be quite a bit fewer than that. It might be 1,000-ish that are actual new unique records to screen. So I export that from Scopus as an RIS file. As a reminder, RIS, I think stands for Research Information Service. That's the universal file format that all citation managers and Covidence can read. So you'll have an RIS file with 2,400 documents in it. You'll import it and remove the duplicates. If you use Covidence for this, here's what it looks like. You can import into the screening stage. You can tell Covidence that these records come from citation searching, and then upload your RIS file, and it will bring in all of those new records, automatically removing the duplicates. Covidence will automatically generate your Prisma flow diagram, and this is just a very simplistic example that I created as a demonstration, but it will tell you, it will automatically populate the flow diagram. And as long as you specify in Covidence here how you found these articles, it will label them appropriately in the flow diagram. And here's what that looks like in the downloadable Word version of that document. it'll say citation searching 25. It automatically puts that over here in the databases search field, but you could put it in citation searching over here to the right. Either one is legitimate. So this is explaining what I just mentioned. This is a really good article that came out 2 years ago on just answering some frequently asked questions on Prisma and how to report things. So as I said, citation searching is Prisma usually puts it in column 2, which would be over here on the right. But Web of Science and Scopus are databases, so do they go over here? And the official answer is you may want to put all the citation searching results on the right and reserve the left for reporting your database searches, but you don't have to. As I said, there's really no published guidelines that go into detail on how to do this. So a lot of it is just figuring out what's feasible and what's most feasible for your team and what's most transparent for your reader. Another quote I pulled out from this article that I really liked is essentially asking, when I'm doing my Prisma flow diagram in my final published review, am I supposed to report all the records that I identified, meaning those 2,400 records from Scopus, and then count the numbers that go through each stage, just like we did with the database searches? Or do I only include the number that were actually in the end included? So let's say from those 2,400, I removed all the duplicates, went through all the titles, and I ended up including 4 articles that I found through my forward citation searching. Am I putting 4 were included, 4 identified through citation searching, or 2,400? So as they say here, best practice is to count all of them, meaning the 2,400. But if it's not possible or feasible, report what is feasible. And this may be especially true if you don't have the capacity to export everything to your citation manager and you're just clicking through in Scopus or Web of Science or Google Scholar and reviewing them that way, just doing sort of live searching and reviewing what comes up as you read it and saving things one by one. It may not be possible to count all the records. So again, just try to be transparent and keep as many notes as you can. One question that comes up when we're talking about citation searching for reviews, and also when doctoral students are doing research, is the rabbit hole effect. So by this, we refer to the fact that you do citation searching and identify X number of additional articles. Then you can do citation searching on those articles that you just identified. And if that leads you to more articles, do you do citation searching again and again? This is that snowballing process we talked about. And sometimes our doctoral students can feel really overwhelmed when they fall down the rabbit hole in this way. This is a reference from Alice in Wonderland, that there's always more out there and more and more and more, and you're never really going to get to the end of all the literature, right? There's always going to be something else there to review. So it's up to your team to decide, we're going to do one round of this, and whatever we identify, that's what we identify, or we're going to do 2 rounds or something. So in theory, this could keep going and going. Of course, eventually you're going to see diminishing returns on this, and probably at some point we'll stop identifying new relevant things. But it's perfectly legitimate to just say we're going to do this once on all of our included studies. Finally, as I said, there's a lot of aspects of citations and bibliometric analysis, as it's called as a field, that doesn't really relate to systematic reviews, but I wanted to make reference to some tools that are used to create visualizations of citation networks and that scholarly conversation I was talking about. Scopus and Web of Science both have visualization components if you want to look into those. There's a few other ones that are free internet tools that you can look into: VOS Viewer, SiteNet Explorer, Research Rabbit, and Citation Chaser. There's others too, but these are just a few that you can look into if you want to see things like how to, if I want to make a nice graphic of everyone who cited a particular study and then the branches of study that came off of that one, you would use one of these tools to do that. I am not a huge user of Citation Chaser, but I tried it out for this before this presentation, and I wanted to show you what that looks like. Citation Chaser is a discovery tool, meaning that it's designed specifically to help with this type of citation searching for systematic reviews. So what you start out with, Citation Chaser, and you'll see the link in the chat, is a list of identifier numbers, DOIs, for all of your articles that you're including, everything you've identified that you're including in your study. You paste those digital object identifiers into a box on the Citation Chaser website. And you can get this if you're using Covidence. You can, whoops, I'm sorry. You can export all of your included studies as a CSV, which is a spreadsheet, and then simply copy and paste them. Or you might be using Excel to do your data extraction, and in that case, copy the DOI from there. So you just paste it and then create a set of input articles. So these are my 26 articles that I am including in my review. For each of these, it will tell me how many references are at the end of the article, in this case 70 for this one, and how many times it's been cited. It will do backwards and forward citation searching, and you can export them as an RIS, which is what we did in Scopus. But the advantage of this tool is that you don't have to look up each article one by one. Imagine if you had 40 articles and for each one you were looking it up in Scopus and adding it to a saved list. It doesn't take that long, but this is faster. So I could export these RIS files to my citation manager to review. And then finally, I just wanted to mention, when you're reporting this in your final manuscript, your publication of your systematic review, I just wanted to give an example of what that looks like. It's very simple. Backwards and forward citation searching were conducted on all included studies. If you wanted to go one step further, you could say backwards and forward citation searching were conducted using Web of Science or Scopus. You could say backwards citation searching was done on all included studies and relevant systematic reviews, etc. So it's very simple. That's all the content I had. Before we take questions, Addie is going to put the evaluation link in your chat. I'm going to stop the recording.